928. Minimize malware spread 2. This problem is the same as I didn't see the first one, so it's fine. Well, I don't think so anyway. Maybe I'm wrong. In a network of nodes, each node I is directly connected to another node J if and only if graph of I so, graph of ij I comma j is equal to 1. Some nodes initial are infected by malware. Whenever two nodes are directly connected and at least one of the two nodes is infected by malware, both nodes will be infected by malware. The spread of the malware will continue until no more nodes can be infected in this manner. Suppose M of initial is the final nodes infected within the malware in the entire network after the spread of the malware stops. We'll remove one node from the initial list, completely removing it and any connections to this node from this node to any other node. Return the node that is removed with minimize M of initial. If multiple nodes can be removed to minimize M initial, return such a node with smallest index. It sounds... It sounds like some kind of weird bridge finding thing, but or connectivity thing. That's my initial thing. That's my initial thing. I'm not. Don't hold me to it. Let me kind of look into it a little bit. So the number of nodes could be up to 300. And well, I mean, this is just what they tell you. A node is connected to itself and so forth. I think my first kind of reaction is, well, can I do this in a brute force way? And what is a brute force way? Well, the brute force way is when we move a node. If I remove a node, can I do a DFS on the rest of the forests to see it? I think you, and that runs in O of V plus E, right? So that's okay. Even if E is V squared, given that we have an adjacency matrix versus adjacency lists. So that's V cube. 300 cube is probably a little bit on the close side. Is it? Yeah, 27 million. So, but then you have to do that for each whatchamacallit, for each node. So that's actually n to the fourth. So n to the fourth is probably a little bit on the slow side. So I don't think I'm going to do that. It still reminds me a bit of bridge finding, but not really. I really hope this isn't a max flow question. But, And actually, I mean, you can, using Floyd Warshaw, using that, which is n cube. No, it's V plus E. Sorry, I said stuff that was wrong earlier because Floyd Warshaw is n cubed or V cube. So then the naive algorithm with respect to that is n to the V to the fourth. But actually, I think I just mixed stuff together. But at depth first search, it's only V plus E, which is V squared at most, and we do V iterations of it, and that should be just V cubed, which should be good enough, I want to say. I think I'm going to do that. And I think the only other thought I might have is trying to think if there are any pre-processing we can do, but maybe not. Is this the right path? N cube, which is 27 million. That sounds reasonable enough, fast enough, right? Okay, so this graph is bidirectional, so we don't have to worry about some daggy thing. Okay, I think I'm going to do that. Because how many items are initial? Well, I guess it could be as many, but that's the number of things that we're DFSing. So okay, I'll do in C. Not gonna lie, what some of my inclination to do it in C is just because I know that it'll be slightly faster, and Yeah, and I'm doing very basic things anyway, so should be okay. Okay, just gonna do that. What am I doing? Okay. Let me get, was it 300? Oh, I guess I should do it the normal way. Oh, what am I doing? Maybe I should actually put this in a thingy. Okay, so it shouldn't be that bad. It goes, I guess, max, because at most you can affect all of them. I think our loop, the loop that we want is, graph size. If that node is removed, okay, and only that node, okay, yeah, only one node, so that'd be really bad if I misread that one. But let's just say okay, so now we reset the graph. Well, actually, I can, maybe I'll just use a sub. Maybe this is an opportunity to be clean. There you go. I have to return to index. Yeah, I guess so. Okay. And now to the calculate function. Okay. How do I want to do that? Just do that for search, but I didn't take out the initial. This is okay. I guess I should need that here. Need that here. Sources. Something like that. And then afterwards, we just count the number of things we've seen. Max. No graph size. Huh, I don't put graph size anywhere. Oops. Oh, I guess I used that. Okay. press escape. This actually should be a word. I don't really need it to do anything. What am I doing? Okay. To I. But only if I is not skip. I think there's an edge case where you skip the initial node. Well, actually, I guess they tell you that's well that's one of the examples. So I just want to make sure that I keep that in mind a little bit early. But let's see. Oh, I guess and also. Is that enough? Okay. This is mostly okay. At least it's what I expect. But okay. But there might be something minor that's incorrect, and that's fine. Relatively confident about this one, but at least if the algorithm is right. If it's not, then who knows? Why would that? Oh, this shows the number of infected. So actually, I minimized the wrong thing or whatever. Oops. Because 2 is right. That means that. Wait. Give it a second. No, it would infect 2. 2 is right. But we want to minimize it. Why does this? Well, oh man. Okay, well. Now let me get some cases. I might have to think about some edge cases actually. I kind of was a little heads down on this one and we didn't really explain anything. So also, if you have any questions, please ask. Sometimes I don't know what I explained and what I didn't. Okay. Okay, let's try one without any. Okay, so you have at least one node. But is there a 2-node situation? Yeah, I think the only thing I have to try is the 300 node one, but I'm kind of lazy to type that all up. Am I? Should I just do it? Or okay, I mean. So I just want a full graph in that case, right? Okay. Oh my god, that's gonna be so much typing. Or like a lot of margins of error. That's 20, 30, 40. Okay, so that should be 300. What happens when I want this? Well, I don't know what that means because it should be nonsensical anyway. But I'm gonna just print out the graph size just to see if it is actually graph size of 0. Just make sure that is 300 elements. Okay, so that's true. Okay, cool. I guess the next one is actually graph size. So I think so. One thing I am trying to be a little bit better at in general is just like patience, especially if I am a little bit ahead on time. So otherwise, I've been YOLOing a lot, and I keep on getting incorrect on like silly things. So that's okay. That's 4, 8. This is like impossible to. I should have just written a program to do this. Maybe that's part of the fun. Let's do it. I don't think I got 300, but okay. I don't even know what that means, but I just want a good test. What is going on? I'm just gonna write a script in batch. Hang on. Or at least do it in Emacs so I don't do it in a silly window. Actually. Hold up. Sorry, friends. Turns out the hard problem is testing it. Okay, that's roughly right. How did it? Okay. Okay. Okay, whatever. Because at that point, I've done what I can, right? Cross fingers. Oh no. Huh. Off by a lot, even. Huh. And it's 40. Well, I mean, I guess these are just indexes, so not always off by a lot necessarily, but let's take a look. At least I know I don't time out, which is always good. Possibly there's an off by 1 somewhere. Yeah, I think so, right? Because this is the first entry that comes up. But yeah, I mean, I think that's why I'm testing it. It goes me up to 39, right? Okay. Yeah. This is, so they want the answer to be 32. But there are a lot of answers that should. I returned 15. What? That doesn't even. Does that make sense? Oh no, that's the min. The second index. So 29 is 15, and then 32 is 31. Huh. Maybe I'm missing something obvious. Yeah, I mean, from what we could see, it seems like my code January thinks 15 is better. because this is a strictly thing. So like if they're equal, which means it comes in later, then this would contain the earlier index. So I think that part, I think it should be okay. Is this code? Man, this is, I don't even know how to debug this particular thing because it is weird looking. 32 is one of the entries, so maybe I handled 32 in a weird way. Well, actually, let me double check the description. Maybe I just made an assumption incorrectly on the removal. Let me double check. Okay. Because I think maybe in this case, maybe I misunderstood part of this problem. I think even if you remove a node from the initial list, it might still count as being there's a malware on that problem, and maybe that changes the math somehow, or like the calculation somehow. Let me I wonder if that's true. Let's kind of take a look. Because I have this here, because I wasn't sure if that's the case, to be honest. But no, I still show 15. I don't know if that's sufficient. 15 only gives 32, and 32 returns 32. So that's like 3 more nodes. Oh, man. This is a very tricky problem to debug also because this is my input. Like how would I... At least we know the algorithm's fast enough. Am I assuming something wrong? When 2 nodes are direct, maybe I do this. I don't know. And this graph is not a DAG, so it shouldn't matter the order in which we do the DFS, I think. Even come close. Huh. And I actually don't really have a great way to visualize this. I think that's my kind of issue. Usually I'm a better debugger, but well, I would like to think so. But like, yeah. Okay. Well, that's fine. I'll do something more brute forcey. Because so how I usually like to debug is that once I get a case, I would try to figure out how to reproduce getting that error on a similar or like on a simpler to type anyway, a smaller case that only isolates the part where we have issues. But yeah, do I do something silly somewhere? All right, fine. Let's kind of see what this is all about. I'm gonna be upset with something trivial that I'm kind of bugging on. I was hoping to do multiple ones too. But, I should have added a space. But okay, fine. 32 is the supposed answer. Maybe the skipping thing only helps it, so I don't know. What? Oh, this still sees 32 for some reason, so maybe, oh well, I think because I have this here, but I'm not quite sure how to count that one out of what you see in the code, but okay. Man. Not gonna lie, I'm a little stumped, mostly because I don't have a great way of visualizing this. I mean, I almost hesitate to look for paper and like draw out this damn graph, but it's a little messy. Maybe I could start by removing some rows. And then 15 is, I mean, 15 just doesn't get 0 because it's 0 the only, yeah, I mean 0 is the only person that. Let's see what happens to the answer by just remove 32. Would I still be right? This is half cheating, but I don't really have a good way of visualizing this. No, so okay. Some weird thing. So I'm just wrong in a lot of ways, actually. Okay, then maybe I could even simplify the problem a little bit more. Just trying to get the simplest problem in which I get it wrong. Okay, so actually that's... so then we can maybe hopefully find a simple version to visualize to kind of figure out where the bug is coming from. Okay, so this is good. 6 is causing us some issue. And 6 is... oh my God. This thing is talks itself, and okay, maybe I should just print it out, but usually it goes slightly smoother, but thanks for bearing with me. Is it off by 1? Is it off by a bunch? So if we remove 1, it has 31. Remove 25, it has 27. Is there something wrong with my... That'd be fun if I just have some kind of weird index issues, which sometimes has known to happen, but why is this so dramatically low? 125. Now I'm just going to point out the graph. Oh. Okay, so there's more, but that's fine. 25 is... Oh my god, I'm never going to figure out how to debug this. Why is it off by that much? That's the part that I can't figure out. It's not even off by one. It's like off by a lot. And there are even other numbers that are kind of low. Oh man, I am just blind. So we will move one node from the initial list, not from any node in the list. I am... Reading comprehension is kind of hard. Okay, let me double... Oh my god. Sorry, I'm just like upset at myself, to be honest. Oh my. If that's it, okay. I mean, at least I'll be happier. Okay, I mean, at least it's still wrong, but I think there are a couple of things that I made changes to that may be a little weird. But it's possible that okay, I mean, at least it's still wrong. Is that good? I don't know. But I'm surprised that that passed all the tests, or initial tests, but okay, I guess we don't need this. But now we could I mean, this is still wrong, even though it's not the. Oh wait. Am I returning the index of the initial, the name of the. I think this is actually wrong as well because we actually want this. I think. Oh my god, I have trouble reading clearly. Okay, let's see if this works here. Okay. Oh my. Oh my. Oh well. Okay. At least my efforts are not in vain, but it doesn't work with that one. I think this is one of the. Oh, it's a tricksy case because these are probably tied, and I'm supposed to return the low index. Okay. I think I was just a little tired from debugging the wrong thing for a long time. So index is bigger than I. Then if index equals I. Okay. But this probably needs to be. I guess I could just look at this 0, 1. Okay, I mean, hopefully that will. Okay, cool. Yeah, man, 19 minutes for that silly bug. Well, the good thing is, I mean, there's some good things on this side. There's some sad things on this side as well, which kind of which will come up in a. I mean, okay, let me start over from the post-mortem. I think in terms of difficulty, I think this is just. I mean, obviously, you require some graph knowledge and some sort of kind of what's it called, connected in a like basically just a depth first search. I mean maybe it's not quite connected components, but yeah, just about like knowledge about getting depth first search and kind of analyzing it in terms of complexity, which I kind of did earlier. But to iterate, depth first search is v plus e, where in this case e is v square. Otherwise, maybe you could do an adjacency list if e is dramatically lower than v, but in that case, in this case, v is equal to v squared, and you only have apparently even less than v nodes to remove. You only have to, this goes up to v, I guess. So that's v cube. So there's a v cube algorithm, and when v is 300, it runs in good time. So yeah, so I think that's kind of the way I think about it. This is just a standard-ish depth first search problem. To be honest, I'm not 100% sure why it's a hard problem. It seems a little straightforward, but I mean, I know I said this while taking 20 minutes to debug it because this is a really hard problem to debug to just visualize, right? Because this is what I get as an input. But at the end of the day, I did kind of make silly mistakes. The first one being that I didn't read that you can only remove a node from the initial list. I think I blame it now that I read it like this. I blame a little bit on kind of the wording on the problem because the initial like this should be like in like bold or italics or whatever, in code format, because I think I just read this as like initial list, like the initial list of nodes or something like that. I don't know, but I think that would probably have helped me kind of catch this a little bit earlier. But yeah, but that said, I think hopefully anyway, if I was in an interview with this problem, hopefully the interviewer would kind of interject with kind of what I went wrong here, because they should know what the problem was. Yeah, so I think that was wrong. I think as a result, when I finally fixed it, I did forget about the part about the node with smallest index, just because initially, I mean, not to blame anyway. Initially, this loop just goes from I to n, and therefore the first one would always be the smallest index. But once we kind of change it to sources sub I, it's no longer be true. I mean, you could kind of still actually keep the same code. I mean, I kind of hacked it a little bit. Not really, maybe it's still good time, but you could actually get about it by also sorting initial to kind of so that you do them in order, but that's that is okay. As an interviewer, I think this is an I mean, I definitely would not classify this as a hard problem. I think this is a good. I think this is a reasonably okay amount of code. I think the only problem, I mean, because if you break it down to components, it's just a depth of search, and maybe there's some stuff about brute force. But if I want to kind of if I were to say to test interviewee's ability on depth of search, I may want to choose something that's less like trivial. Like this is essentially depth of search. There's not that much complexity, and there's like some brute force on it. But I mean, that's fine as a problem. I think like I don't know, it's a little weird, but it's okay. I think I myself might not be a fan of it just because it's a little bit straightforward. But in terms of problem solving, I think like. But I guess at some point, like if you don't know depth first search, then you would probably have a lot of trouble with this. But if you did know depth first search, it's just following the instructions. I mean, I would like to think I did it very quickly, minus the fact that I took 20 minutes on this. I did 18 minutes otherwise. So I doubled my time because I misread one part of the problem. But yeah, but otherwise, I think this is okay. It's not too difficult, but and it's not too much to type up. I think there's just, I think the actual prompt statement could be a little bit clearer, but I think in terms of concepts, it's pretty straightforward. So I think it's